Hello Titans, welcome to Chapter 13, Section 3. Today we're going to talk about the fundamental counting principle. Go ahead and get your notes out and write some of these examples and some of these important points that we are going to cover in this lesson down. Alright, here's a quick teaser question for Chapter 13, Section 3. Police use photographs of various facial features to help witnesses identify suspects. One basic identification kit contains 195 hairlines, 99 eyes and eyebrows, 89 noses, 105 mouths, and 74 chin and cheeks. The developer of this kit claims that it can produce billions of different faces for the suspects, or for witnesses to choose from, in order to help identify suspects for police. Is this claim that this company is making about their kit correct? What do you think? We will answer this question at the end of our lesson today. Alright, let's jump right into the fundamental counting principle. The fundamental counting principle says if you have two events, then one event can occur m ways, and another event can occur n ways. Then the number of ways that both can occur is m times n. Let me use as an example making sandwiches, which is one of Mr. Simpson's favorite things to do. Event number 1. There's 4 types of meats, and event number 2 is 3 types of bread. So if you have 4 types of meat and 3 types of bread, how many different sandwiches can you make? Well, the fundamental counting principle tells us that if we have 2 events, we can just take the number of ways that those events can occur and multiply them to find the total number of options. So how many different types of sandwiches can you make? Well, you take the 4 types of the meat times the 3 types of bread, and that tells you that you could make 12 different sandwiches. Now, if you're curious about that, another way to do it would be to make a tree diagram where you could go ahead and list the types of meat. So, for example, and I'll just use an abbreviation, you could just say ham, turkey, bologna, which is one of my favorites, and then we'll say chicken. And then you can go off of there and you can say the types of bread. So it's wheat bread, white bread, rye bread. And if you notice, we could make a tree diagram, and if we made a tree diagram and looked at all the different combinations that you could possibly have, you would see that it would be the same thing, 12 options. So the fundamental counting principle tells us that if we want to find the total number of ways that something can occur, we take the first event times the second event. Now, I wonder if there's 3 or more events. Well, 3 events can occur m, n, and p ways. Then the number of ways all 3 can occur is m times n times p. So that's the fundamental counting principle. So for example, let's say we had 4 meats, 3 cheeses, and 3 breads. How many different sandwiches could we make? Well, we would take 4 times 3 times 3. So guess how many different sandwiches we could make? 36 different sandwiches. That's the fundamental counting principle. Alright, here's an example. At a restaurant at Cedar Point, you have the choice of 8 different entrees, 2 different salads, 12 different drinks, and 6 different desserts. How many different dinners, one choice of each, can you choose? So how many different dinners can be created? Well, what we would do is we would take event 1, which is 8 different entrees, times event 2, which is 2 different salads, times event 3, which is 12 different drinks, times event 6, which is 6 different desserts. So 8 times 2 times 12 times 6 would tell us that there's 1,152 different dinners that are possible to create. Now, if you ever see a place, for example, I've seen some places like, for example, you might see Subway say, come eat at Subway, we have over 1 million different sandwiches. And you're thinking, wow, they have 1 million sandwiches? Well, the way that number gets multiplied quickly is the fundamental counting principle. When you have different meats, when you have different breads, when you have different toppings, all of that adds up pretty quick. And you're thinking, geez, these places don't really have that many sandwiches. Well, they do have the ability to make that many different sandwiches because of the options that they have. Alright, another example here. We have the fundamental counting principle, this time though with repetition. And this is kind of the second thing we want to teach in the lesson. Here it says Ohio license plates have 3 numbers followed by 3 letters. So my question to you is, how many different license plates are possible if digits and letters can be repeated? Well, think about this. It's 3 numbers. So for your numbers, you got 0 through 9. So there's 10 choices for your numbers. And then for your letters, there's 26 choices for each letter. So to find the total number of plates that could be created, we would take 10 times 10 times 10 times 26 times 26 times 26. And when we multiply that out, we can see how there could be 17,576,000 different plates. Alright, now let's take a look at this next question. How many plates are possible if digits and numbers cannot be repeated? Well, there's still going to be 10 choices for the first digit. But since numbers cannot be repeated, whatever number we use for the first digit cannot be used for the second. So that would leave only 9 choices for the second and only 8 choices for the third. For the letters, there would be 26 for the first, but only 25 for the second and 24 for the third. So how many plates are possible if digits and numbers cannot be repeated? Well, as you can see, that's going to shrink our number because we go 10 times 9 times 8 times 26 times 25 times 24, which would be 11,232,000 plates. Alright, phone numbers. How many different 7-digit phone numbers are possible if the first digit cannot be a 0 or a 1? Obviously, and this probably goes out to more, this lines up more with guys. If a girl gives you a phone number and she says, hey, my phone number is 032, she's lying to you. The first digit can't be 0. That calls the operator. And it can't be 1 because 1 is used for long distance. So some of you guys that have probably been getting phone numbers from girls that start with a 1 or 0, that's kind of a quick tip for you. Now let's look at how many different phone numbers could be created with this information we have here. So obviously a phone number has 7 digits. And the first digit can't be a 0 or 1. So how many options are there for the first digit? Just 8. Then 10 for the second, 10 for the third, 10 for the fourth, 10 for the fifth, 10 for the sixth, 10 for the seventh. So if we multiply all those out, there could be 8 million different phone numbers. And once again, we're just applying the fundamental counting principle here. Alright, testing. Have you ever taken a test and wondered, man, if I guess all these, what are the odds I would get them correct? Well, a multiple choice test has 10 questions with 4 answers each. So how many different ways could you complete the test? 4 for the first question, 4 for the second, 4 for the third, 4 for the fourth, and so on. So if you took 4 times 4 times 4 10 times, you would have 1,048,576. So if there was a 10 question multiple choice test, what are the odds that you could just guess for every question and get them all correct? Well, not very good, because as you can see, there's 1,048,576 different ways to complete a simple 10 question multiple choice test. So that shows you that you're not well off to just simply guess. Alright, to end our lesson, folks, we'll go back to the teaser question. If you think back to the kit, is the kit claim correct? Well, yes it is. Because they told us that we had 195 different hairlines, 99 different eyebrows, and so forth. So if we went ahead and we multiplied all those up using the fundamental counting principle, you can see that this kit that they have, the claim is correct. They could make over 13 billion different faces. Alright, ladies and gentlemen, that's the fundamental counting principle. Hopefully you enjoyed the lesson and you can use this information to go ahead and complete your assignment.
Made with Doodlecast Pro.